Assalamu alaikum everyone, and today we are going to talk about base 10 logs and natural logs. So remember this scientific calculator I have? Well, you probably have if you have been watching some of my old videos, because this comes very often in algebra and trigonometry. And if you want to see more of my scientific calculators, then just notice the calculus tutorials, algebra tutorials, and trigonometry tutorials. And you can visit some of my old videos, but that out of the way, notice this button. Let me show it a bit better to you. Here, this button. Why is there no base in this button? I'm about to show you why. Now, mathematically, whenever there is no base written, it would automatically be called log to the base 10 because it's the common log. Because base 10 logs are also known as common logs. Now, it's to say that whenever you go down, it's 10 times more of that. Like the pH scale of acidity and basicity in chemistry, that if you go down, you get 10 times more acidity, and if you go up one more, you get 10 times of basicity. Oh, and for some information, 7 will be neutral, but that doesn't matter. What matters is that this is the common log. That's why mostly it'll be written without the 10. Logs are not 10. Basically, all you need for the base is it to be greater than 0 and the base not to be equal to 1. These two in mind, if it fills both, then it will be a valid logarithm. Not only 10. Plus, the log base does not have to be an integer. An integer is basically -1, 0, +1, and it cannot be a fraction. It doesn't have to be an integer. For instance, it doesn't even need to be rational, which is basically a ratio described. See these two types of numbers in our types of numbers video. I'll link it up in the cards. Now, it can also be an irrational function, an irrational base, like e, which is equal to 2.718 28459, and it keeps going on forever and forever, repeated without repeating. Now this is one of the more, this is called a natural log. Now, how do we derive it? We have an expression for it. We have this expression that is 1 plus 1 over n full n, meaning it will be 1 plus 1 over the unknown number, all to the exponent of that number that was in the denominator. Now let's say we have salary of $1, but the more we work, but there will be a raise. So let's write the n value, expression, and total. So if you have $1 of salary, but it's counting for 1 year. 1 year salary will be $1. Now let's say your raise will be up to a year. So the expression will be 1 plus 1 over 1, all to the power of 1. Now if we do all that, we will get not 1 but 2. Yes. This might get a common mistake, but 1 over 1 is 1, and 1 plus 1 is 2. 2 over 1 is 2. Now if you say half a month, you get $2. Then we get 1 plus 1 over 1 half to the whole square. So here it will be 0.5, so 1.75 times 1.75 in the calculator will give 2.25. Now if it's saying per month, we get a raise of $12. Then it will be 1 plus 1 over 12 square, all to the power of 12, and it becomes 2.613. Now if we counted it per day, we get an increase. Then 1 plus 1 over 365, all to the power of 365, we will get 2.715. Now if we did the raise continuously, meaning infinitely, which is not arithmetically compatible because it will be undefined, because we will have infinity in the denominator and we have infinity as an exponent, which both will make it undefined, especially the denominator part. So here, if we did the evaluation, it will be close to E. Now the additional sum of it, we get less. Like there is more difference to 2 and 2.5 than there is of 2.5 and 6. Like we get more money the more we count it, which is a bit surprising, but according to this expression, this should be the one. And E is a number that is mostly equal to 2.71 828 and going all the way up to infinity, and a few infinity digits, and if it's right in digits, then you know it's an approximation, because it will never be this value. It will be more, as the dots represent. So now log to the base e of x can also be written as lnx, and this ln abbreviation will be known as the natural log. That's what this is in the scientific calculator. For a closer look, let me show you. Here is the ln button in a scientific calculator. It's basically telling e should be raised to what number to get x. Now, if you have a log, such as log to the base 7 of 15, we have to use the change of base property. Now the change of base property goes like this. Log to the base b of x will be equal to log base b of x divided by log base a of b. 1.682 would be equal to 4.98537265. Now if we checked that to the rounding we gave, this is approximately correct. Approximately correct. So this is what you will need to solve for something if you have another log. As you can see, 14.99 is approximately 15. So our answer is approximately correct. So with that, that's all there is to it. Remember to subscribe if you want more logarithm videos or basic math and science, or if you want to just, so that's all there is to it. If you want more algebra videos like these, or trigonometry or calculus, which will come eventually, or just science basically, then you can subscribe to this channel and ring the notification bell so that you can get notified whenever I make a video. And trust me, when I say whenever. But if you're interested in coding, check out my second channel, which will have all about coding, which is in the link in the description down below. And you can like this video if you enjoyed it. You can share this video to more people or any people you know that has similar problems. And thank you for watching, and I will see you next time. Bye.